Hello everyone, hope you're all keeping safe. Speech technology has become very popular over the last few years. Personally, I myself have been working on speech recognition and speech synthesis over the past 2 years. So there were times when I had to go through many hoops to solve problems that I encountered. So I thought it would be a good idea to make a series of very short presentations where I present some significant problems in the process of building an ASR model and also point some ways to solve those problems. So I thought this would be a useful resource for fellow learners. So let's get started. So in this particular presentation, I'm going to talk about how to create a label dataset for speech recognition. What do I mean by that? So you have this scenario where there is an audio and a transcript of the audio. So this kind of data can be used to train an ASR model, speech recognition model. But what if the transcript is not accurate? What if the transcript is approximate? So what do we do? So this is a extremely common real world problem. So you have if you're building any app or any system which requires speech rec and you want to train your own speech rec models, chances are very high that you will have, for your particular accent and for your particular dialect and domain, you might have approximately matching transcripts, but you might be wondering how we can train an ASR model using any of the toolkits, whether it's Caldi or Deep Speech or any other toolkit of your choice. How can we do that? So intuitively, you need some sort of like alignment algorithm, alignment procedure which aligns the audio with your transcript. So this is actually a very well studied problem in speech technology and is referred to using the term force alignment. So here I have the definition of force alignment. So it refers to the process by which transcriptions are aligned to audio recordings to automatically generate phone level segmentation. So forced alignment is very similar to ASR, to the task of ASR, except for the difference that in force alignment you already have a transcript, and what you're interested in is estimating the timestamp of the tokens in the transcript from the audio. So forced alignment can be based on different things. So it can be based on, you can have a purely monophone level force alignment. So monophone meaning like single phones, or you could have like diphone, triphone, word, syllables, and you can even align with respect to specific phonetic classes like vowels. So you only want to do force alignment based on the vowels in your audio, in your transcript. So similar stuff. So there are many different techniques to do force alignment. I will not go into those details here. At the end of the presentation, I have a slide on some useful links, and there is a link to the CMU page on long audio alignment, and that has many papers and theses that you can refer to. But yeah, so in this presentation, I will only talk about one particular way of doing force alignment. So yeah, in my work, I've used the Caldi open source toolkit to build ASR models. So there are a few Caldi based force alignment toolkits. So the most popular of these is the Montreal Force Aligner, So yeah, again, I would encourage you to read about the Montreal force aligner. But in this particular presentation, I'm going to use another aligner which is called the gentle aligner, mainly because it has a Python API and it's much simpler to use. So again, I would encourage you to read the code of the gentle aligner, but I present a very high level summary of what it does. So when you have an audio, it reads the audio in chunks, and for each chunk in the audio, it transcribes the audio using an ASR model, pre-existing ASR model, and then it estimates the alignment between the transcript that you gave, and the transcript of the chunk extracted using the ASR, using an algorithm called dynamic time warping. So yeah, I think you should read about dynamic time warping, and you know, it's an algorithm that has application in a wide array of problems. So I would encourage you to read about dynamic time warping. Uh, and I think that's it. So this is the useful links page. So these are some of the things that I read while preparing these slides. And let's actually move on to a quick demo of how this works. So this is the repository of Gentle. So again, I will not get into the details of how to install Gentle. So you can read the instructions, you can read the documentation and install it. And for this demo, I'm considering this example from YouTube. So I just took this audiobook reading of Robin Hood Chapter 1, and I'll be using that to do the demo. Okay, so yeah, so I assume that you've installed Gentle. So yeah, so it can be a bit complex. So you would have to look at the code and basically make sure that everything is installed correctly. So okay. So this is our transcript. This is the transcript of the YouTube video, and I also extracted the audio of that. So let's quickly listen to it.
Robin Hood by Stephen Colborne. Chapter 1. Robin of Locksley. Robin Hood was born in the small town of Locksley in Nottinghamshire. Locksley's buildings were made of wood, and it was smoky and dirty, like many other towns in England. Robin's father owned a small farm, which didn't have very much land. Life was sometimes very hard.
Yeah, so this is the audio. As you can see, there is the preamble of the audio which has some music, etc. So those parts will not be relevant because they are not present in the transcript. So let's see how Gentle does the alignment. So there is a Python API in Gentle which is align.py, and I'm going to give nthreads as 3 because I have a laptop from 2012 which only has 4 processors. Okay. So now it's aligning the audio with the transcript. So yeah, as I mentioned, what it does is it divides the audio into chunks based on frames and reads one chunk at a time, transcribes it, and then gets the alignment. So yeah, the code is really easy to follow. So I think if you read the code, then it'll all become very clear to you. So it's going to so one of the features of gentle aligner is it also does a multi-pass alignment. So it aligns so it aligns the transcript in a first pass, and then it takes those alignments and does a second pass of alignment. So we'll see that now. Okay, so you can see that after the first pass, there are 335 unaligned words out of 660. So the accuracy of the pre-trained model, the pre-trained acoustic, the Caldi model, is on this particular audio in the first pass is like only around 50%. So there are 50% of the words which are not aligned. So now it will do the second pass. Okay, so even after the second pass, you can see that there are around 200 words which are not aligned. So that's almost, you know, 1/3 of the transcript. So the pre-trained model is actually not very good because it's not able to transcribe the audio file that we have. But nevertheless, for this demo, we'll just take this example and then see how things work. So now we have the alignment in the JSON file. So the next step is I have this very short Python script which will extract the aligned audio bits. So basically I pass the audio, the transcript and the alignment file, and it'll extract bits of audio which are aligned, and you can actually use those straight away to train your own speech recognition models. So yeah, the logic is very simple. Again, I think if you read the code, you can understand the entire algorithm. So I think I'll just extract aligned audio bits, audio, pulse. Transcript. Sorry. Yep. So it's already extracting the aligned audio bits. Yep. So you will have many utterances. So again, to keep things simple, I only extracted sentences which were fully aligned, where the start word and the end word was aligned. So you can play around with that, and you can extract a lot more utterances if you tweak those parameters. So let's look at some utterances. So it's Robin of Locksley. Yeah, so you have the aligned bit. Similarly, let's go for Father, please let me go to Nottingham, Robin said. So now let's see if that's what we have.
Nottingham. Father, please let me go to Nottingham, Robin said.
Yeah, so that's what you have. Okay, let's do one more. I'm sure that Marianne will marry me for love. Okay, so let's do this.
I'm sure that Marion will marry me for love.
Yeah, so you have the aligned audio bits and you have around 38 of them. So you can just do this on many audios and create several thousand hours of aligned audio bits. And using those aligned audio bits, you can tune existing acoustic models, you can train your own model, and this can also help you train acoustic models for new domains like clinical domain. It can help you train acoustic models for new dialects like Irish English or Scottish English, or any other new dialect of English for which you don't have a good speech recognition model. So that's it from me today. Hope you have fun force aligning your audios and transcripts. Bye.